is Mrs. Often, coming to you live from my kitchen. I'm here to talk today about equality of matrices and matrix operations. So our two questions are, what makes two matrices equal? And also, what operations can we perform with matrices? So by the time you're done, you'll know what makes two matrices equal, and you'll also be able to perform some basic matrix operations above and beyond the elementary row operations that we've already studied. First, let's look and see what makes two matrices equal. Two matrices, A and B, are equal if and only if they have the same order. So they're either both 3 by 2 matrices or 2 by 1 matrices. If they're both square matrices, they're both 2 by 2 or they're both 3 by 3. And their corresponding entries are equal. So here's an example of two equal matrices. This one is 1, 3, 2, 4, and this one is also 1, 3, 2, 4. Now if I switched around any of the numbers, let's say that I traded two of these numbers along the non-main diagonal, you could say, hey, it has all the same numbers, but it's still not equal. So now that's no longer two equal matrices. These matrices are not equal because this matrix is a 2 by 1 matrix and this matrix is a 2 by 2 matrix. So I don't care that they start out looking the same. This one's like missing half of it. So not equal. Now, why do I care if two matrices are the same order? Well, if two matrices are of the same order, they can be added. Now, they don't have to be equal to be added, but they do have to be of the same order. So, I'm going to add these two matrices. This is a 1 by 2 matrix. It's also a 1 by 2 matrix, so I can add them. And I add by adding the corresponding entries. So I have 1 plus -3, that's -2, and I have 2 plus 6, that's 8. So my answer here will be -2, 8. In B, I have a 2 by 2 matrix and another 2 by 2 matrix. Again, I can add these two matrices. So I'm going to get 1 plus 7 is 8. 2 plus -2 is 0. 0 plus 5 is 5. 7 plus -1 is 6. We could also have subtracted these matrices by subtracting the corresponding entries. And yes, order matters for subtraction of matrices, just like it does for subtraction of real numbers. So it's a way that matrices and real numbers are the same. Okay. This, in C, I have a 2 by 1 matrix and a 1 by 2 matrix. These matrices are not of the same order, so we can't add them. So too bad, no adding for you. Okay, so again, you can add if they're of the same order. Now we can also multiply a matrix A by a scalar, K. I don't know why they chose K, but we'll notice matrices, they get noted with capital letters. So in order to do this, I'm going to multiply each entry of the matrix A by that numeric value, or that variable value even, K. So here, A is a 2 by 2 matrix, 5, 3, 0, 1. K is -2, so to find that scalar multiplication product, Ka, I'm going to take -2 and multiply every single entry by -2. So -2 multiplied by 5 is -10. -2 multiplied by 3 is -6. -2 multiplied by 0 is 0, and -2 multiplied by 1 is -2. So that's scalar multiplication, which is not too bad. Sometimes we can even multiply two matrices together. So matrix multiplication is weird when we compare it to real number multiplication, because any two numbers you can always multiply together, any two polynomials you can always multiply together. But matrix multiplication, it turns out you can't always multiply two matrices together. So when can we multiply two matrices? Well, if you're given two matrices, A and B, the product AB exists if the number of columns in A equals the number of, not columns, rows in B. So, if I have a matrix A and it's 3 by 2, and another matrix B that's 2 by 1, the columns in A is equal to the number of rows in B. Excellent. I can get that product, A times B. What will the order of that answer be? Well, I can just cross off what's in the middle here. My AB result will be a 3 by 1 matrix. But let's say I try to switch this around. Okay, now B is a 2 by 1 matrix, and A is a 3 by 2 matrix. Look, the number of columns in B does not match the number of rows in A. So AB does not exist. Okay, and what's even weirder about matrix multiplication is not only that sometimes it works and sometimes it doesn't, even if you haven't changed the matrices, you just changed the order, is that also it's just not commutative at all. So with numbers, 2 times 3 equals 3 times 2, well, in matrices it is very rare and only under certain conditions that A times B is equal to B times A. We'll talk more about when those conditions occur a little bit later on in another video. But right now, let's look at two examples of matrix multiplication. I chose two 2 by 2 matrices to multiply in each of the examples because I think they're easier and you'll get what the methodology is more easily from watching it. You may want to watch this a couple of times just to be sure you get it, and definitely practice and try doing it on your own. What I do is go across the row and down the column. So, in order to multiply, I'm going to do 2 times 0 plus 1 times 1. Then, I'm going to go across first row times second column. 2 times 2 plus 1 times 3. Now I've covered all my columns. That's going to give me my entire first row. Now I go on to this second row. 3 times 0 plus 4 times 1. Then, moving on to the second column, 3 times 2 plus 4 times 3. Simplify everything. 0, that's 1 is 1. 4 plus 3 is 7. 0 plus 4 is 4. And 6 plus 12 is 18. Okay, so with my 2 by 2 matrix multiplied by another 2 by 2 matrix, I got a 2 by 2 matrix for my answer. Okay. So now that we've done this, you can see that I should be able to multiply a 2 by 2 matrix by another 2 by 2 matrix, and I should get an answer that is a 2 by 2 matrix. So let's do this. Okay, I have 1 times 5 plus 0 times 1. Then moving to the second column, 1 times 3 plus 0 times 7. Next, moving on to my second row, 2 times 5 plus 6 times 1. And 2 times 3 plus 6 times 7. Okay, I'm going to get a huge answer down here in the 2-2 entry. So we'll simplify. 1 times 5 plus 0 times 1, well that's 5 plus 0, or 5. 1 times 3 plus 0 times 7 is 3 plus 0, or 3. 2 times 5 plus 6 times 1 is 10 plus 6, or 16. 2 times 3 plus 6 times 7 is 6, plus 42 is 48. So my final answer here is indeed a 2 by 2 matrix. Took up a lot of room there. It's 5, 3, 16, 48. Some great practice that you can do after watching this video. Write your own set of 2 by 2 matrices, A and B, and find their product. Bring it to class and we'll trade and talk. So that's your introduction to matrix operations.